Okay, so I'm just going to go through the process of working out resultant forces using the graphical method. Put simply, resultant forces are talking about when you've got two forces acting on a point and they're at an angle to each other. The resultant force is the force that becomes in between that. So if our point is here, and let's say we've got a 2.4 kilonewton force acting here at a 45-degree angle, and we've got another pulling force here that might be 4.2 kilonewtons, okay, and that's at 45 degrees. The resultant force is what's going on in this space here, okay? So to do this using the graphical method, we can use a scale rule. It's simple enough to use a regular rule as well without a scale on it, but a scale rule does help. We need a protractor as well, and it's particularly helpful if you use graph paper, although that's also not entirely necessary. Okay, so what we're going to do to start with, guys, is we're going to have our anchor point, and then I'm going to go and represent the 4.2 kilonewtons, and I'm going to do that by drawing a line that is 42 millimeters long. So as you can see there that I'm using a 1 to 10 scale, alright, representing 4.2 kilonewtons by 42 millimeters. Then I'm going to grab my protractor and set it up. Hopefully my head's not in the way when I do this. I'm just making a mark there at 45 degrees. And then I'm going to use my rule again, and this time I'm doing 2.4 kilonewtons, which is going to be represented by 24 millimeters. Alright, so there we've got our angles, and that's 45 degrees in the middle. And this might be that, you know, let's say you're pulling a load here that might be a trailer or something, and you've connected two ropes up to it, and you've got one friend that's a bit stronger than the other. One friend is able to pull at 4.2 kilonewtons and the other friend is only able to pull at 2.4 kilonewtons. But they're both acting on the load, and we're trying to work out what the resultant force is in the middle here. So what we do, guys, is we use our parallelogram rule by coming to the end here, and I'm going to make another mark at 45 degrees. Sorry that my head's in the way. And I'm going to come up here again at 24 millimeters. We can complete the parallelogram. You don't really need to, I suppose, but okay. And then our resultant force is going to be what we're left with in the middle. Now you can go and measure about there, and in this case we are finding that the resultant force is 62 millimeters, which of course converts then to 6.2 kilonewtons. Oops, got that round the wrong way. Little k, big N. Okay, but we also want to work out what the new angle is in here. So we can use our protractor to work that out, and we can find that that is at 16 degrees.